I'd like to start by returning to this concept that lists are stored as addresses to lists. So when I say y is equal to a list and x is equal to y, there's really only one list in memory. And so because this is a really important concept, so I want to do a little bit more on that. So let's look at this little bit of code up here. It's a function called reverse list. It takes as input a list. And we've already seen this. We've already written a reverse list, but let me just remind you. For I in range 0 to the length of the list divided by 2, so we're going to look at the first half of the list, j is going to be an index into the corresponding last element in the list. So if I is 0, j will be the length of the list minus 1, and then we'll increment, decrement, increment, decrement, increment, decrement, and then we're going to swap those elements. So remember that we swap by holding on to the ith element, setting the ith element to be the jth element, and then setting the jth element to be the one that we held into the temporary variable. Okay, so this is just reversing a list. We've already seen it. If you don't remember this, just go back to that earlier lecture on list reversing. All right, so there's my function for doing it. I send the list in. It does this little bit of code. And let's make sure we understand what's happening now when I call that function. So I'm going to define a list to be test list that has 8 numbers in it. And if I print that test list, of course, I just get those numbers. That's obvious. Now I'm going to call reverse list with test list. So I'm going to go into here, and it's going to do this little thing. But notice it's changing the variable L, right? So my test list is out here, and I'm passing that list in. And typically when you pass values into a function, they're just values. But we know that lists and integers and strings and booleans are stored a little bit differently. So in fact, what I'm sending in here is not really the list, but it's the address of the list. So now test list and that little L variable are both pointing to the same list in memory. And what that means is that when I call this reverse list and then I ask what is test list, it has itself been reversed. Even though it looks like I'm reversing that little variable right there, but again, I'm passing in the address. So when I make modifications inside of a function, they have this ripple effect because of the nature of the way lists are being stored. All right, so now let's see what happens when I do this. Okay, here's my test list, same as before. New list is equal to test list. All right, now at this point we know what happens. There's 2 variables, they're distinct variables, test list and new list, but they both store the address of that list right there. Okay? Now, call reverse please on new list and then print new list. What's going to happen? Of course it will be reversed, right? Same as up here. But now when I say print test list, what happens? It's also reversed. Because now new list and test list both point to the same list. When I called reverse list on new list, that little variable now points to the same thing that new list and that test list point to. So any modification to a list will ripple through all the variables that are pointing to the new list, to the same list rather. So that may seem a little weird, but it's fine. It's just that's the behavior of the code. But what you may want to ask is, well, what if I have a list and I want to reverse it, but I don't want to clobber this? So that is, I really want a copy of the list. So of course Python gives you the mechanism to do that. Test list is equal to same list, square bracket, 8 elements in the list. Instead of saying variable is equal to test list, I say variable, and I'm now going to call it copy list, is equal to list of test list. And what this tells Python to do is says, what we want here is not a copy of the address. We want a whole new list. And so now what Python does is it takes this list, makes a new copy of it, and hands back a new address. And so at this point in the code, test list and copy list don't know anything about each other. Test list points to 13579.13.15. Copy list points to its own version of that. So now when I call reverse list of copy list, and I print copy list, of course it's reversed. That's to be expected. But when I print test list, it is not, because I've decoupled those lists. and now I'm treating them as if they were integers, distinct copies. Okay? So that little list command allows you, when you really want to make a copy of something, sever these two variables, and then you can do whatever you want with them without them clobbering each other. So this notion, again, of storing lists as objects is really important. It's going to become particularly important in a few weeks. All right, a couple more commands you should know about lists that are built into Python. So Python has a automatic sorting list. So if I create a list here of the Ivy League schools, I've put Harvard last because it's by far the worst Ivy League. I say that, by the way, because I taught at Dartmouth College, which is the best Ivy League, for 20 years, so I'm still a little biased. So Ivies is equal to this. You can sort these alphabetically, alphanumerically, or numerically by calling the built-in function sorted. It takes a list, it makes a copy of it, and hands it back to you into whatever variable you want, and it will be in sorted order. So that's just a nice little function that Python gives to you for sorting lists. We know how to create a list. Here's one right here. We know how to modify a list. So if I wanted to change the dwarf's name, I would say dwarf sub 1 is equal to whatever. But what if I want to add an element to the list? What if I wanted to put grumpy at the very end here? I can't say dwarf sub 6, 0, 1, 2, 3, 4, 5. I can't say dwarf sub 6 equals grumpy because there is no dwarf sub 6. So what if I want to add something to a list, append something? Well, of course, Python gives you a mechanism, and here's what it looks like. Dwarves dot append grumpy. So what is dwarves? It's the name of the list. What's append? It's a built-in function associated with lists in Python, and then you pass it as a parameter, the string grumpy. Now, what is this dot notation here? We've actually seen that before. All right, I'm not going to be able to explain it right now, but let me tell you that this, again, is a hint into objects and classes. That this is a function associated with a data structure, and the way you call it, not always, because here's an example where you don't do it, is using this dot notation. And we've seen this dot notation with the graphics. Draw dot. Yeah? It's going to turn out that dot notation comes from a very special place, and we're pretty close to learning, so just hold on to it. But for now, just know this is the syntax for adding an element or appending an element to the end of the list. There it is right there. Now, I can also insert anywhere in the list, not just replace. Similar type of syntax. Dwarves, that's the name of the list. Dot insert instead of append. 1, that is the position I want it in. Remember, you start counting at 0. Grumpy. And so I can I can add a new element, not just at the end here, but into any position using the insert function. So append is just put it at the very end. Insert allows me to add it anywhere. And the last thing is, how do I take something out of a list? Okay, I can't say dwarf sub 1 equals an empty list. That'll just put an empty list in there. So you just say del, D-E-L, dwarf sub 1, and it will delete what was in the 1 position. Now, I find this a little annoying in Python that the syntax is different. Why isn't this dwarves.delete of 1? It's a syntactic sugar thing, and you just sort of have to get used to these slight inconsistencies in the syntax. So appending and inserting, doing things like sorting, and deleting elements of the list are going to come in really handy as we start to manipulate data. All right, let's end this with a drill. So write some code that computes the length and position of the largest list in a list of lists. All right, let's make sure we understand. I give you a two-dimensional list, as you saw before. Each element can be a list. They can be of arbitrary length, including empty, and I don't care what they are. They can be number strings. Do as numbers for now because that's easier. So I have some number of strings, lists. Sorry, I have one list with some number of elements. Each of those may have a variable number of elements in it. 1 element, 3 elements, 10 elements, 0 elements, 4 elements. I want you to tell me two things. What is the length of the longest of those sublists, and what position is it in? 0, 1, 2, 3, or 4. So you have to hold on to two things. How long is the list, and where is it? So there's a bit of a logic that you need here. And so I'm going to ask you really, I've been saying this over and over again, I'm going to say it over and over again, turn off your computer and sketch out the algorithm. Think through the logic of this. This is non-trivial. I can think of at least two solutions. I'm going to show you both of them, when you come back. So go ahead and pause the video, please, and sketch out this code, write it in Python. Obviously, you want to test this, and you want to test it well, because put your longest list in the first position. Put your longest list in the last position. And by the way, for now, don't worry if there's two lists with the same length. I don't care what you do. Pick the first one or the second one. It doesn't matter to me. All right? All right, good luck, and I'll see you in a few minutes with my solution. All right, here's my first solution. All right, here's a sample list of lists. This list has 4 elements. The sublist has 3, 4, 2, 1. So the answer to what is the longest sublist is 4, and what is its position? It is 1. That's what I should return. So let's look at my code here. So let's see, I've got some variable definitions up here. I've got a for loop here, and this is, of course, my print statement with the answer. So max length equals 0, max pos equals 0, I equals 1. All right, so I'll come back to those 3 variables in a minute. We're going to use them. For L and L, so big L is my list. What is this for loop doing? It's going to assign to the variable little l the list 1, 2, 3, and then the list 4, 5, 6, 7, and then the list 8, 9, and then the list with just 10 in it. Okay? So L will literally be those sublists. And what do I want to know? I want to know, is this the longest list in the whole thing? Okay? Well, at this point, I only know the length of this list. I don't know what to compare it to. So what I'm going to do is I'm going to keep a running track of the longest list. Right? So think about how you would solve this. I look at the first list, sublist, and I say, oh, this has 3 elements in it. Is that the longest? How the hell would I know? I have no idea what's in the rest of the list. All right, let's go down. All right, that has 4 in it. That's bigger than 3. So that's currently the longest sublist. Is it the longest in the list? Don't know. Let's go to the next one. 2, well, that's no better. 1, well, that's no better. Done. That must have been the longest sublist. So at any moment, I'm going to look at how long the list is. I'm going to ask, is this the longest that I've seen so far? And I'm going to keep going. So max length and max pos are those running lengths and pos. And I'm setting it to 0 because I know at the very beginning I've got nothing, and I'm going to assume there's at least one sublist in here with a value with a length greater than 0. So if length of L, which is now 1, 2, 3, is greater than the current max length, which is 0, then set max length to be that length. So after the first iteration, that will be 3. The max position is 0 because I've set, oops, that's a typo. That should say I is equal to 0. Sorry about that. Yes, that should be a 0. Okay, so that should be max pos is equal to 0. And that's, at this point, that is my best answer, right? Now, I'm going to go to the next sublist. Come up to the for loop. What's the length of this? 4. If the length of 4 is greater than 3, that was the last max length, then reset the max length to 4. Its position is going to be equal to 1, and then increment I by 1, because now we're going into the next sublist, and keep doing that over and over and over again. And eventually, you get to the end of the list, and you will have held on to the max length and the max position. Now notice here that because I'm tapping into the element of the list, I have to keep track of, again, that should be a 0, I apologize, I have to keep track of the actual index position. That's my responsibility because this is only giving me the element of the list. I'm going to show you a solution that doesn't have to do that. And when I get to the end, outside of the for loop, I'm going to print the max length is, convert the max length to a string, at position, convert the max pos into a string. Okay, good, perfectly fine solution. We have to keep track as we are going through this list. What is the maximum position? Now, something that's a little clumsy in this solution is what I was just mentioning, which is this variable and this variable. I have to keep track of this position. And there's nothing fundamentally wrong with it, but I find it a little clumsy. But I had to do it because of the way I wrote that for loop. So let's try a solution that doesn't require me to keep track of it. All right, so this will work perfectly fine. Same list, max length, max pos is 0. And now I is not going to be the string 1, 2, 3, the string 4, 5, 6, 7, etc., etc. It's going to be the indices 0, 1, 2, and 3, the position. Yeah? And now what I'm going to ask is if length of L sub I is greater than max length. So now all I have is the position, but now I know how to get that list. Just L sub I, there it is right there. I test the length of that against the max length, and if it's greater, then I reset the max length to the length of that sublist, and the max pos, there it is. It's just I. I don't have to keep track of a new variable now, and then I have the same print statement. So you can see this is a little cleaner here. I don't have that extra variable. I don't have that increment here. And the reason why this makes more sense is that it's trivial to tap into the sublist given the index. But if I only have the sublist, I had to go to the extra work of keeping track of the index, and that was not great. So if I had to, both solutions work, but if I had to pick one, I would pick this solution. Now there's one little thing bugging me about this solution, which is right here I'm computing the length of the list, and right here I'm computing it again. And that, it's not a big deal, but there's this slight inefficiency here. So maybe I can do a little bit better. So let's see if we can fix that. So what I'm going to do is once I'm in this for loop, I'm going to just ask, well, tell me what the length of the sublist is, because I need it in two places. Look, arguably this has very, very small difference when you're dealing with lists like this, but if the list has a billion entries in it, and you're looking for the longest sublist, every time you're doing a double calculation, which doesn't seem worth it. So when you find yourself doing that same computation twice, just define a variable. It's much cheaper. So now I have it, and then I can use it here, and I can use it here. All right, good. So I hope you got that drill. A little bit of logic on how you keep track of things as you work your way through the list, keeping track of information. All right, that's it for lists, and we're ready to move on to the next topic. So we'll pick it up on the next series of lectures in a few minutes. I'll see you in a little bit.